fuck up. Okay guys, so this time I decided to record in audio and set up subtitles. So here I have the rotor, and I'm just gonna show you and the magnets. I'm just gonna show you how I laid the magnets on the rotor. And I made the rotor with pairs of 2 magnets, so it will be each pair the same polarity, which will be positive positive and then negative negative, positive positive, and so on. I'm just laying them on the holes so you have an idea of how is it going to be. They're very sticky. So these holes are 6 millimeters each, as the magnets. They are 6 by 6 millimeters. Now they are a little bit hard to fit in, but with a filer I will just give it a little scratch on the inside, not much because I don't want them to be loose, so they can fit well. But for now I'm just more or less trying to show you how they're gonna lay on the rotor. So I already laid the first pair, and the first pair it's positive to the inside. The second pair will be negative to the inside. So, and it will be like that all around, positive negative positive negative. So 2 magnets are positive, 2 are negative. The stator that you see on the desk, now it has the normal winding, the one that comes in the stator. But that only works with the other magnet that was inside the rotor, the flexible one, because that one has around 6 poles. Once it's wrapped inside, it provides with 6 poles more or less, and or yeah, I think it's 6 poles, and that will give the alternating current in this stator, the way it's laid down, because this is a 3-phase stator. So the windings go like 1, 2, 3 poles, and then it changes to the other side, and so on. They are not in series like I'm going to do, because I'm doing like the way I'm laying the magnets. They are also 12 poles for saying. So I will have to lay the windings on the stator also as 12 coils, imagining 12 coils. So I will wound one coil clockwise with 100 turns of very thin wire. I'm sorry, I don't remember the gauge of the wire. I know that more or less 3 of those wires make 1 millimeter, so it might be a 34 or 38 gauge, I don't know, 36 maybe. I'll show you in the video the thickness of it. So I will wound one for the positive will be clockwise, the negative will be anti-clockwise, and then clockwise, anti-clockwise. But I'll do that with the same wire. I'm not gonna make one coil and then keep 2 wires out and then do another coil and then attach solder the wires. No, I'm just gonna wrap one coil and then move on to the next and wrap the other coil clockwise and anti-clockwise. And in the end I'll just have 2 end leads, which makes it well, I would be also with 2 end leads if I had to solder them all, but it makes it more clean job, and that way I can also unwrap the wire if I want some time and make it reuse it for something else and just wrap another wire, thicker wire, and that gives more current. So here it is. This is more or less how I'm gonna lay the magnets on the rotor. Of course they're gonna be a little bit deeper. Now they are just on the surface of the inside, but I'm gonna lay them a little bit deeper in the rotor. I'll just knock it a little bit and put some glue, super glue, just to keep them in place. and that's it. So let's move to the other. Okay, now so here we are. Now it's time for the winding of the coils. I already wind some of the poles in the stator. As you can see, the wire is very thin, and now I'm doing a positive pole, and that pole it's being wind clockwise, as you can see. I just have a calculator so I don't lose how many reps I've been doing. So I just sum 10 turns and then make equal, and then it sums another 10, and so on, so on. So it's a very slow process. Here I am. You see, just make equal, and it's 410. I have 410 turns already because I have 4 coils already wrapped. Um, so now I'm winding this one. As I was saying, it takes a little bit time, but it's worth it, the effort. I'm just making a 100 turn winding on each pole. I could make a 200, which would give me more voltage and also a little bit more current. In this case, I'm looking for voltage because I know already that I can put out with this wire, if I have 12 poles with 100 turns each pole, when I'm at 7 volts, I get around 400 milliamps hour. So it's enough for me. But I can always go after I make all the windings in this stator. I can always go with a little bit of the same wire and just wind more turns on each pole again, and then just solder the leads on the end, and that will give me more voltage and more current also. So I didn't want to wind too much because I wanted to see how it will fit inside of each pole on the stator. 100 turns, it's quite good, and they fit nicely. I believe I can put probably another 100 turns each pole. So, but for now, for testing and seeing how much current it is and voltage, I'll just stay by 100 turns each pole. I'm also using, since it's a very thin wire, um, I'm using 100 turns because of that, because it's a very thin wire. I can make more turns, but if it's like a half millimeter wire or 1 millimeter wire, you can give less turns and it will give you less voltage but also more current. So keep that in mind. The thicker the wire, the more current you get and less voltage you get. And, the way I'm winding this, on the stator, this will give me a, a coil winding in series. I could make them in parallel, which will give me less voltage but more current also. But for now I'm happy this way. This is just for testing and showing you guys that you can build a stator, a generator that produces a good amount of voltage and current. So I'm already at 470 turns in general, but just this pole, it's just 80 turns now. So as you see, I'm doing it clockwise, and once I get to the end of the winding, I will change to anti-clockwise. Because if I do all clockwise, it will just not work. Because once the magnets, the poles are positive in one side, it will be positive in the other side, so that doesn't work. What we want is when it's positive in one side of the stator, it has to be negative in the other side of the stator, and so on, so on. So because otherwise you wouldn't have alternating current. You would just induce current in the other coils, and then it will just stick, and that's it. So we are 500 turns. We were doing clockwise. Now we go to the next one and go to anti-clockwise, as you see, and we will move on like that until all the stator is wind. So let's move next. I will just wind all the windings on the stator, and I'll bring you back to the stator already all wind. So let's do that. So here we are now with 1200 turns winded on the stator. As you can see, the stator is finished. They are positive in clockwise and negative anti-clockwise, and so on, so on. So you just grab a lighter, because this is a namelit wire, so you have to burn the ends. So you take the resin off, and then with a little bit of sandpaper, you just scratch the rest and to clean the ends. Now we're gonna measure how much current and voltage this generator is doing. Just have to fit inside, and that's it. So it has a lot of torque. Just plug the crocodile leads on the end of the wires. Snug and nice. Change the voltmeter to alternating current, and you start spinning it. I'll just bring the voltmeter for you to see. And as you can see, just with a little turn you get 7 volts. When it's at 7 volts it gives you those 400 milliamps, sometimes 500 milliamps. And this is just with 1200 turns in general. Um, you can charge your phone with this. I've tested. I don't know if I have a video of that. If I don't have it, I'll just record a video of that and I'll show you that you can actually charge your phone with that. Just gonna plug this to an LED so you can see that it's actually producing voltage. Sorry, my throat is a little bit sore. Um, so I'm just gonna test with this. With the light, it's a little bit hard to see. Um, I'll probably, but it does light the LED. I'll just turn off the light so you guys can see better. Yeah. I'll just wrap the wire on the LED so it's because the wire is very thin and on a breadboard it just doesn't get inside. It's always losing itself, getting out of the holes. So I'll just wrap around the end leads of the LED and just I'll show you that it's actually producing voltage. I'm not gonna spin too much because otherwise it would burn the LED, but as you can see the LED is flashing just with soft turns. I'll turn off the light for you guys to see better. As you see, just by turning it slowly, it just produces already the voltage. It is already generating voltage, so it's proof that you can make a generator with this. You could already with the way it was, but I like to change things and show how they can be. How they can be hacked to produce more voltage and generate more current. So that is a nice thing. So now let's move to the part where I transform it to continuous current. Um, Here we have the bridge rectifier. This is the bridge rectifier that I'm going to use. I already soldered the leads on the stator where the current comes out and the voltage. And I'm just gonna attach this to the voltmeter and show you guys now the voltage that it's putting out, which is more or less the same as alternating current, but in this case it's stable. It's direct current or continuous current. So you have to change your voltmeter to continuous, and you can start spinning. That is continuous current. That is alternating current. So just change it to continuous. With the bridge rectifier on, you see it's a little bit more soft than if it's alternating current. I'll probably use some diodes so I don't get back EMF from the other coils, which it's in general it's not. I don't need that, but it's always good to use that because you have some circuits that you will attach, and you will need the diodes for that. So I'm gonna test again with an LED, so you guys can see again that it's still producing the current, and this time the LED lights a little bit better, more continuous. It doesn't flash like it was flashing. If it goes slow, it will blink. But if it's my cat is just asking, yeah, Mel, you have food there? And as you saw, the LED just lights better than if it's just alternating current. And also you can use now to charge your phone with the bridge rectifier. You can use it to charge your phone because you're already getting the continuous current. If you on the end of the leads, the motor gets stuck, and that's what would happen if you had to wind the coils all in one direction. It would produce the same. It would be inducing current. So here I have an aquarium LED lamp, LED light. This is like to imitate the sun light outside. Normally it's connected to a transformer that it's 12 volts and 600 milliamps of current. And I've just put the leads wrong. So bear with me. I will change the leads. I changed the polarity, so that's why it's not lighting on. But at the speed I'm gonna spin this, it's not even generating 12 volts. It's around 7-8 volts. But still, it will light this light, this LED light. And that's because it's first it's because it's a high voltage, high current generator. So you can see the current is high. It's not 20 milliamps or 30 or 50 milliamps. It's actually producing more than 500 or 400 or milliamps. I will turn off the light so you guys can see better, but you already can see it just by spinning a little bit. And with a bridge rectifier, since the LEDs use continuous current, they would light on with alternating current also, but it's preferable to use a bridge rectifier. So just by spinning a little bit, it produces a good amount of current, and it lights this stripe of LEDs. I don't know how many LEDs are, but quite a few. And as you can see, they are very bright. So if you have this with a windmill or something like that, you could have this on for a long time and charging a battery and then just reusing it. So there you are. This is the generator working and producing the voltage and current that it's needed. See you in a bit.